Hi, if you are passionate about data and also love basketball like I do, you might really enjoy this video. NBA teams use a lot of stats and advanced analytics and actually change the way they play based on data. If you ever wondered if you can have access to this data and work with it, you can. The NBA provides a REST API with numerous methods for extracting different datasets. To get started working with a dataset, you will need to make several different API calls and parse the data response. My ultimate goal is to use this data to create my own dashboards and use it for machine learning to derive insights. However, before I start and use machine learning, I will have to create a repeatable process that can fetch the right data by making the right API calls, parse, clean, and structure the data so I can easily work with it. At the end, I will use machine learning to find which stats have the best predictive capabilities for specific players and teams. These stats might be influencing winning games more than we think. In the next couple of videos, we'll walk through how to orchestrate a process that will fetch the right data, perform advanced analytics and machine learning with Talend and Databricks. My process is triggered by the Talend Cloud Console. Here I can select the team, player, and the season for which I would like to fetch data. The job has 4 steps. First, it will make all of the API calls required to fetch the data for the selected team and player. Second, the data will be uploaded onto a cloud storage and structured into corresponding folders. The third job will use Spark on a Databricks cluster. It will join simple and advanced statistics, create Spark SQL tables, and prepare a secondary dataset for machine learning for teams and players. Here, we can even calculate additional features that are not part of the dataset, like days of rest before the game, amount of minutes played in the previous week, and so on. Finally, the last job will trigger 2 Databricks notebooks using Python to perform feature selection for machine learning and k-fold model validation for the data. Feature selection in machine learning is the process where you select those features which contribute most to your prediction variable, in this case, winning basketball games. I am not really interested to predict the outcome of a specific game for a given game stats sheet, but rather find which stats influence the game result the most. The notebooks triggered by my Talend job ran some Python code to select the best features for players and teams. The results are interesting and are different for each player. For example, for James Harden, we can see that these 6 stats can predict the outcome of the game with 83% accuracy. Even though James Harden leads the league in scoring, the stats that predict winning for his team are more related to his passing, defense, and rebounding. Of course, this is a small dataset. For teams, however, I have collected a bigger dataset from the past 2 seasons with over 2,000 games. After carefully selecting the best features, we can see that with only these 6 features, I can predict the results of the games with 84.7% accuracy on a dataset that is almost completely balanced, 53% win-loss ratio. Like most cases, this data will change daily, because every day more games are being played. Since my Talend job is completely automated, I can schedule my process to run daily, fetch the latest data, and re-evaluate my model. You can summarize it like this. Data analysts who don't organize their transformation pipelines often end up not being able to repeat their analysis. So I would give the same advice often given to traditional scientists. Make your experiments repeatable. If you're interested in a deeper dive into the results, together with a closer look at the NBA Talend orchestration job, how to do machine learning feature creation with Talend, what is recursive feature selection, check out the technical deep dive video for this demo. Thank you for watching. See you next time.